What is redundancy in cloud computing? Redundancy in cloud computing refers to the duplication of critical components or functions within a cloud environment to increase system reliability and availability. The idea is to ensure that if one component fails, another can take over without affecting the system's performance or availability. This concept is essential in cloud architecture, especially for businesses that require high availability, minimal downtime, and robust disaster recovery strategies. Key concepts associated with redundancy. 1. High availability HA. High availability refers to systems that are designed to operate continuously without failure for a long time. Redundancy is a core component of HA as it ensures that multiple instances of critical components are available. For example, if one server in a cloud environment fails, another can immediately take over, ensuring uninterrupted service. Example, in a cloud service hosting a website, multiple web servers can be set up to handle traffic. If one server goes down, the others can continue to serve the website without any noticeable impact on users. 2. Fault tolerance. Fault tolerance is the ability of a system to continue operating properly in the event of a failure of some of its components. Redundancy plays a significant role in achieving fault tolerance by providing backup components that can seamlessly replace the failed ones. Example, in a cloud-based database system, data might be stored across multiple servers, data redundancy. If one server fails, the data can still be accessed from another server, ensuring no data loss or service interruption. Hamshur 3. Data redundancy. Data redundancy involves storing the same piece of data in multiple locations within the cloud environment. This ensures that if one data storage location becomes unavailable, the data can still be retrieved from another location. Example, in a cloud storage service like Amazon S3, data is often replicated across multiple data centers, often in different geographic locations, to ensure that it is safe from localized failures, such as a power outage in one data center. 4. Geographic redundancy. Geographic redundancy involves duplicating systems and data across multiple geographic locations. This is especially important for disaster recovery and ensuring service availability in the event of a regional failure, like a natural disaster. Example, a global online service might host its servers in multiple continents. If an earthquake disrupts servers in one location, servers in another location can take over, ensuring that users around the world can still access the service. Have 5. Load balancing. Load balancing is the process of distributing network traffic across multiple servers. It works closely with redundancy by ensuring that if one server becomes overloaded or fails, the traffic can be redirected to another server. Example, an e-commerce website may use load balancers to distribute user requests across several servers. If one server fails due to heavy traffic during a sale, the load balancer redirects traffic to other servers to maintain the website's performance. Haber 6. Disaster recovery. Disaster recovery involves strategies to recover and restore data, applications, and services after a catastrophic event. Redundancy is vital for disaster recovery because it provides the necessary backups and alternative systems to quickly restore operations. Example, a company might back up its critical data to a cloud provider's storage service. In case of a disaster like a fire in the primary data center, the company can restore its operations using the backup data stored in the cloud. 7. Backup redundancy. Backup redundancy involves creating multiple copies of backups, often stored in different locations or on different media types, cloud storage, physical tapes, etc. This ensures that if one backup fails or becomes inaccessible, others are available. Example, a healthcare provider may keep backups of patient records on both local servers and cloud storage. If the local server backup fails, the cloud backup ensures that the records are still accessible. Real-life use cases. 1. Netflix. High availability through redundancy. Netflix operates globally, delivering streaming services to millions of users. To ensure high availability, Netflix uses multiple redundant servers across different regions. If one region experiences an issue, the traffic is rerouted to servers in another region, ensuring users can continue to stream content without interruption. 2. Amazon Web Services AWS Geographic Redundancy. AWS provides cloud services to businesses worldwide. To ensure service availability, AWS uses data centers located in multiple regions across the globe. Services like Amazon S3 store data redundantly across several geographic locations. In case one data center fails, the data is still accessible from another, maintaining service continuity. 3. Financial institutions, fault tolerance, and data redundancy. Banks and financial institutions require highly reliable systems to manage transactions. They use redundant databases and fault tolerant systems in the cloud to ensure that even if one part of the system fails, transactions can continue to be processed without interruption. Data is often stored in multiple locations to protect against data loss. 4. E-commerce platforms, load balancing, and redundancy. Large e-commerce platforms like Amazon use load balancing to distribute traffic across multiple servers. During high traffic periods such as Black Friday, the redundancy ensures that if one server fails due to overload, other servers can take over, preventing downtime and lost sales. Summary. Redundancy in cloud computing is a fundamental principle that ensures the reliability, availability, and resilience of cloud-based systems. By duplicating critical components and distributing them across multiple locations, cloud providers and businesses can protect against failures and minimize the risk of downtime. Whether it's through high availability, fault tolerance, data redundancy, or geographic redundancy, redundancy ensures that cloud services remain operational even in the face of unexpected failures or disasters.